Welcome to OnlineMaths TV. My name remains Jakes Anemo, and in this channel, we drop new videos every day. Like I promise you, any of the days I fail to drop a video, expect two the next day of it, and I've kept to that promise. All right, now today we have a new challenge. But before we go into today's challenge, if you are new to this channel, kindly subscribe. When you subscribe, turn on the bell notification button so that you can get notified whenever we drop our new videos. All right, let's go into today's challenge. Yeah, here we have the question says bracket open the square root of 2 plus square root of 3 close bracket to the power of x plus close bracket square root of 2 minus square root of 3 close bracket to the power of x are equal to 4. What then will be the value of x? Let's take down our solution. Now, in this question, I'm going to use two methods. Okay, then you now consider or you choose the one you feel best to use. Okay, so we take our solution. Now, in our solution, we take the first method. Let's take the first method. The first method here. It is. We put down our equation first, which says bracket open the square root of 2 plus the square root of 3 to the power of x plus bracket open the square root of 2 minus square root of 3 all to the power of x equal to 4. What if I decide to label or call this equation 1? All right, we'll go to the next stage of it. I want to bring in another alphabet to represent this positive one now. So we can say here, let me say let y equal to bracket open the square root of 2 plus root 3 close bracket all to the power of x. This very expression, let's call this again equation 2. If we label this equation 2, the second part of the equation 1 expression is different from this one. So how do we now manipulate to bring this second part of this? This is what I will do here now. All right. From equation 2, what if I decide to multiply the numerator and denominator of the right-hand side rather of the equation by this? What will now become of it? In other words, let me put it in writing. Say multiply the numerator and denominator of equation 2 by the expression square root of 2 minus root 3 all to the power of x. So if I do that, this expression equation 2 will now become bracket square root of 2 plus root 3 close bracket to the power of x dot bracket the square root of 2 minus square root of 3 all to the power of x all over your square root of 2 minus square root of 3 all to the same power of x. This has not really changed equation 2 because this and this can cancel out to give us equation 2 back. Now, this is raised to power s, this is raised to power s, this is raised to power s. So I can rewrite everything in here as the square bracket of your bracket square root of 2 plus root 3 close bracket square root of 2 minus root 3 close bracket all over bracket square root of 2 minus root 3 close bracket all to the power of x. Okay, this has not really changed anything. And here we are having a square root covering everything, a square root covering everything. So I can actually bring out this square root, and our expression will automatically become bracket open. Then we have the square root of everything. Here we have 2 brackets here. Let me write it well. We have 2 plus the square root of 3 bracket 2 minus the square root of 3 close bracket all over the square root of 2 minus root 3. Okay, all to the power of x. If I open up this bracket, everything is going to give me 1. How? Let's check it out here. We have here 2 plus root 3 close bracket 2 minus root 3. 2 times 2 will give us 4. This 2 times minus 3 will give us 2 root 3. Then root 3 times 2 will give us plus 2 root 3. And root 3 times minus root 3 will give us minus root 9. So this will give this, and this will leave the system because we have a minus sign and a plus sign here. So we are left with 4. Here we have root 9 will give us 3. So minus 3, and automatically we have 1. So the whole of this numerator is going to give us 1. And thus we're going to have here 1 all over root 2 minus root 3 all to the power of x, because 1 to the power of x will give us 1. Okay, let's look at x now. Now that we have this now, mind you, we derive the whole of this from equation 2. So we are still having y equal to this. So this automatically equal to y. If I'm to bring out this expression, because the aim of it is to bring us what we have here now, so that when we want to substitute, we will not have issues. So how do I now bring out this expression from here? This is why I have to find the inverse of both sides. So if I do that, let's proceed from here first. If I find the inverse of both sides, it's going to give me 1 all over y equal to bracket open the square root of 2 minus root 3 all to the power of x. We've gotten the expression we're looking for. So let's take this as our equation 3. So now that we've succeeded in looking for all the terms in there, the next thing we do, we'll now say from equation 1, so put equation 2 and 3 into 8. So if we do that, equation 1 says the square root of 2 plus square root of 3 all to the power of x plus bracket 2 minus square root of 3 all to the power of x equal to 4. So if we do that, from our equation 2, we have the whole of this to be y plus, and from our equation 3, we have the whole of this to be 1 all over y equal to 4. So if we clear our brackets, clear out the denominator, we're going to have y squared plus 1 equal to 4y. All right, now we collect our like terms. We have here y squared minus 4y plus 1 equal to 0. Very simple. Okay, now, you know this is a quadratic equation. So we solve this quadratically, and we cannot use factorization method. So the best method to use here is the formula method. So using the formula method, so from here, we now say solve using formula method. So we have to put our formula. What does it say? The formula says that if you have your y here, from our relationship, we're going to have here minus b plus minus the square root of b squared minus 4ac all over 2a. Let's go ahead and bring out the value of a, b, c from this. The value of a from here is equal to the coefficient of y squared, which is 1. The coefficient of y here is our b. So b is minus 4. And the coefficient of c, c is a constant term. So c is equal to positive 1. So if we put the whole of this into this equation, we're going to have here y equal to minus bracket minus 4 plus minus the square root of minus 4 all squared minus 4 times 1 times 1. Okay, all over 2 times 1. All right. Wow. So we proceed again from here. Take a look at this. Minus times minus will give us plus. So here we're going to have here 4 plus minus the square root. The square of minus 4 is positive 16 minus 4, because 4 times 1 times 1 will give us 4 all over 2. So from here, this is same thing as 4 plus minus square root of 12 all over 2. Now, root 12 can also be simplified, okay, from surd. Root 12 will give us here, can be written as 4 times 3, which is equivalent to root 4 times root 3. And root 4 is 2. So this is going to give us 2 root 3. So the whole of this can be written as here 4 plus minus 2 root 3 all over 2. Okay, something special has happened here. Here we have 4, 2, and 2 here. So we can factor out 2. If we factor out 2, this will now give us here 2 into 2, the plus minus root 3, close bracket, all over 2. And of course, these 2 will go with these 2. We are therefore left with, therefore, our y equal to 2 plus root 3. So we have two cases of y. So case 1, let's say y1 is equal to 2 plus root 3, and y2 is equal to 2 minus root 3. These are the two cases. And from our first equation, we don't have y in the system. We only have x. So how do we now move back to look for our variable x? We now recall equation 2 and equation 3. Okay, so from here, we now say recall. Let's proceed from here down again. If we recall, let's take our first one from equation 1. So we'll now say case 1 of y. When y is equal to, we have here 2 plus root 3. Now say from equation 2, okay, from equation 2, we're going to have this to be bracket open, the square root of 2 plus root 3 all to the power of s equal to bracket 2 plus root 3. Oh, any confusion? No. But before we continue again, if you are new to this channel, kindly subscribe and turn on the bell notification button, because we drop new videos every day in this channel. And any of the day I skip dropping a video, expect to the next day of it. All right, so let's continue. Okay, yeah, we look at this. We are having a square root in here, but this one is not carrying a square root. If I introduce a square root sign to the whole of this and raise it to power 2, that will still give us this. So the right hand side could also be expressed as, okay, let's put down our left hand side first, 2 plus root 3 close bracket to the power of s equal to bracket square root of 2 plus root 3 all to the power of 2, because these 2 can take care of this square root and now expose this back to this. So this expression and this expression is the same. And what we've just done now has already made the left hand side, the content inside the bracket, to be same with the content in the bracket of the left hand side. And so we can now cancel this. We cancel this. And so we equate the exponent, because there is a law that says that if you have a to the power of m equals to a to the power of n, then the base can take care of themselves. They equate the exponents. Okay, so if we do that, we're going to have here x equal to 2. That is the first case. So we now look for case number 2, okay, which is the second case. So we now say case 2. Case number 2, we have our y to be 2 minus root 3. Okay, so from case number 2, we look at equation number 3. Equation 3, okay? What is our equation 3? We now say from equation 3, what does it say? It says 1 all over y equal to, bracket open, the square root of 2 minus root 3 all to the power of x. So let's equate the two. So this will now give us here all over 2 minus root 3 equal to, bracket, square root of 2 minus root 3, close bracket, out to the power of x. This could also be written as, bracket open, 2 minus root 3 to the power of minus 1. Because there is a law that says that if you have 1 all over x to the power of 2, this is same thing as x to the power of minus 2. The 1 and the division sign represent your negative power. So that is what I've done here now. So if we have this, this is equal to whatever we have on the left hand side here, 2 minus root 3, close bracket, out to the power of x. The only challenge we have here now is that here we have a square root here, we don't have a square root here. What if I decide to introduce a square root and a square to this other side again? What will become of this? This will now become your bracket open, square root of 2 minus square root of 3, close bracket, to the power of 2 or to the power of minus 1 equal to, bracket, square root of 2 minus square root of 3, close bracket. Okay, now I can use this to open this because according to the law of indices, it says that if you have a to the power of m, close bracket, to the power of n, we can multiply the power to give us a to the power of m n. So if I do that here, this will give me something special. So let's proceed from here. From here, let's turn back here. Okay, so from here, this will now give us, bracket open, the square root of 2 minus root 3 all to the power of minus 2 equal to your bracket open, square root of 2 minus root 3 all to the power of x. What we have inside the two brackets, the content is the same. And so this will take care of this. And if we do that, then we're going to have here minus 2 equals to x. Therefore, our x is equal to minus 2. So the two values of x now implies that x is equal to, we have positive 2 and also negative 2. QED. All right, let's look at the second method of solving this. Now, from this expression, let's hold this as our equation 1. If I decide to consider only the radicals inside the square root, multiply them, then we're going to have something like this. From here, we'll have 2 plus root 3, close bracket, close here, 2 minus square root of 3, close bracket. What will this multiplication give me? From our first method, we are going to have this to be equal to 1. Let's take this as our equation 2. Now, from equation 2, if I decide to take the square root of everything and take the square root of everything, this will automatically give me, okay, going to give me square root of bracket 2 plus root 3, close bracket, bracket 2 minus square root of 3, close bracket, or equal to the square root of 1. Okay, now From this expression, I can split this square root to this, also split this to this. So automatically, we're going to have this to be the square root of 2 plus root 3, okay, close bracket, then dot the square root of bracket 2 minus root 3, close bracket, or equal to 1. From this very expression I have here now, if I decide to divide both the left hand side and the right hand side by the square root of bracket open 2 plus root 3, what would that give us? So from here, let's put it in writing. Say divide through by the square root of 2 plus square root of 3. So if I do that, let's move forward and see what this will give us. If I do that, the left-hand side is going to give us square root of 2 plus square root of 3, okay, close bracket, all over your square root of 2 plus root 3, okay, into bracket, then times your square root of 2 minus root 3, this root 3 please, okay, or equal to 1 all over the square root of 2 plus root 3. Let's put this in bracket. Okay, any confusion? So from here, this will take care of this. So we are now left with your square root of 2 minus root 3, close bracket, equal to 1 all over the square root of 2 plus root 3, bracket here. If you look at this, we have this inside our equation 1. So let's go ahead and put this equation. Let's give this equation 3. Okay, so from here, if you look at this, because we have this expression in our equation 1, so equation 1 will now become, now say equation 1 will become, and now rewrite equation 1. So this is going to give us here, which is, we have here to be your 2 plus root 3, or into square root to the power of x, plus 1 all over this here, because this is what we have there in the second part. So bracket the square root of 2 plus square root of 3, close bracket, or to the power of x, equal to your 4. And we know that 1 to the power of x is going to give us 1. So this now implies that bracket the square root of 2 plus square root of 3 to the power of x plus 1 all over bracket the square root of 2 plus root 3 into the power of x, equal to 4. Now, this is your equation 1. So we have succeeded in eliminating your 2 root 2 minus root 3. So from this point now, we can now bring it another alphabet. So we can now say put, let's use a p equal to bracket the square root of 2 plus root 3 all to the power of x. So with that, this equation will now become your p plus 1 all over p equal to 4. Okay, so let's proceed from here. So if we multiply by p, we're going to have here p squared plus 1 equals to 4p. So if we reconnect our items, we have here p squared minus 4p plus 1 equal to 0. This is a quadratic equation. And you know, in the other test method, we'll solve this quadratic equation already. So no need to solve that again. So this one, therefore, will now give us p equal to 2 plus square root of 3. Very easy. Okay. We now go ahead to look for the value of x. Recall we said let p is equal to x. So we'll take the case 1. So the first case, which is case 1, we have when p is equal to 2 plus root 3. So we bring in the value of p here, which is bracket the square root of 2 plus root 3 all to the power of x equal to 2 plus root 3. Close bracket here. Just matter of introduce your square root and a power of 2 to this other side. So we have here root 2 plus root 3 all to the power of x equal to bracket root 2 plus root 3 all to the power of 2. Since the two brackets are the same, so this and this will leave. So we now have our x equal to 2. Where the difference lies now is how do we now get the second part now? Okay, so getting the second part is very easy. All we need to do is to go back to our equation 3. Okay, from our equation 3, we can get the value of s from there. Case 2, we look at this now. From case 2, with this, we now look into equation 3. So we now say from equation 3, let's look at equation 3. Look at what equation 3 is saying. So for us to have 2 minus root 3, which is what we have from here now, is to take the square of both sides. Because if we take the square, it will eliminate this. Then we now bring it to this other side. And so from equation 3, we now have here, which is your bracket root 2 minus root 3, close bracket, square this part. Then this will now give you 1 square all over bracket open the square root of 2 plus 3 or root 3 all squared 2. Okay, so from equation 3 now, we just square this to eliminate this. So this will now take care of this. We now have the left hand side to be 2 minus root 3 is equal to your 1 all over bracket root 2 plus root 3 close bracket all square. Okay, so the game is already playing out now. So when we look at this now, we are now having this equal to this. So we can now come to this relationship here now. So therefore, we now have, which now implies that our square root of 2 plus square root of 3 all to the power of x is the same thing as bracket square root of 2 plus root 3 all to minus 2. Okay, so therefore, this expression now, because we now have what we have inside here is same thing here now, so we can now cancel out. So if we strike out this and this, we now leave. So we now have our x equal to minus 2. Therefore, our x is equal to positive 2 and minus 2, like we have from the first method, QED. So any of the method will give you the same answer. Okay, this is OnlineMaths TV, and my name remains Jakes. Remember, I love you, and all of us from OnlineMaths TV loves you too. Thanks for your time. Now, if you have gained something special from this solving, drop it in the comment section by saying thanks, Jay. Okay, and also give our videos a thumbs up. All right, don't forget to also share with friends and family members who need this knowledge. Thanks for your time. Thanks for being there. Bye for now.